So today we will talk about what we call the normal distribution, all right? So until now, right, we've been drawing histograms, right? And if you look at a histogram that is symmetrical, or even if it's not, right? But if you look at one that's symmetrical, look at how it looks, right? The bars here, you can potentially, like, do you see how, like, you can draw a curve on top of it to sort of model the shape of the distribution, right? But look at what happens here. When you do draw that curve, it's kind of an awkward curve because it doesn't match the graphs totally perfectly. You know, you do have some leftover spaces here, right? However, this histogram has 1, 2, 3, 4, 5, 6, 7 classes, 7 bars, right? If I increase that number to, 14, I would have a more, detailed picture, right? But then, or if I increased it to an even greater number, like you see here, right? Okay, if I increased my numbers, right, to an even greater number, look at how different the distribution looks. Look at how detailed it is, right? And now if I increased my numbers even more, right, look at how detailed it is now in this curve. And then eventually, if I make this, infinitely many, right, then what I get here is a cute little curve that looks like this, right? But now in order for us to be able to increase the bars, the number of the bars, we also need more data to go into them, right? We can't just be talking about like 30 people and expect the level of detail that this has, right? So look at what is increasing. In the first case, you have 1,000 people in your data point, right? Like 100 people have been surveyed. Then we increase that number to 1,000, 10,000, and eventually a whole population, right? Thousands and thousands of people. And in that case, you see how you have a smooth sort of trend happening, all right? Okay, so this is what we call the normal distribution, right? So let's see what that is. Some properties of the normal distribution. So first of all, the graph is bell-shaped, right? Which means it's symmetric to the mean, right? So the mean is in the middle here, okay? And the shape is symmetric around the mean. And that's what happens. The more data you have, the more the mean will actually look like the middle of the graph, okay? The mean, median, and the mode, this is important. The mean, median, and the mode are all equal, okay? And they are located at the center. So not only is that the mean, but it's also the median, and it's also the mode, right? And again, this happens when you have a much larger population than a smaller one. Also, the normal curve is continuous, meaning it's not like, discrete bars like this. It's actually a contiguous line. The curve approaches but never touches the x-axis. So you see here, the curve approaches the x-axis, but it doesn't really touch it. It kind of like floats on top of it. And this is the important part. The total area under the curve is equal to 1 or 100%. What does that mean? That means the stuff underneath here, okay, represents 100% of all the people in your survey or in your data set. All right? All right, so that's the normal distribution. All right, so now we're going to work a little bit on this. Let's talk about standard deviation. We've hit on this before. Standard deviation tells us how much the values differ from the mean, right? So for example, if the mean on a test was 85, okay, but all the scores were, like from like 70 to 100, like they're all close to that 85, right? But if the mean was 85 and the scores ranged from, let's say, like 50 to 100, then there is a greater spread or a standard deviation. So another way of saying that is the standard deviation measures the variation in data. Values close together have a small standard deviation. Like I just said, the units are the same as the original data, right? So for example, if we're talking about like height, okay? Height of, I don't know, students in the school, okay? The standard deviation of like how far apart they are, like whatever you measure the height in, like inches or feet, it'll be inches or feet. Okay, here, this is important now. For many data sets, we call a value unusual, okay? That's the term, okay? It's not derogatory, it's just not usual. If it differs from the mean by more than 2 standard deviations, okay? All right. So what does that mean? So suppose the mean, right, of some, there's an island and you measure everybody's height, and the mean, the average height on that island is, let's say, 60 inches, okay? That's 5 feet, all right? And suppose the standard deviation is 3 inches, okay? Now, from 60 inches, if you go up 1 standard deviation, that's 63. If you go up another standard deviation, that's 66. That's 2 standard deviations, right? So from 63 to 66, that's 2 standard deviations. Now, if somebody's height is 67 or higher, because it's 2 standard deviations away from the average, we call that an unusual height. That's all it is. All right? So like there's nothing wrong with the person, right? But he's just far from the mean in that group. Okay, so let's talk about the shape of a distribution based on the mean and standard deviation. All right, so take a look here. You have two, you see how both the red and the blue are normal distributions? The reason why they're normal distributions is this is the mean, right? That symbol, that's a Greek letter mu. It makes the m sound for mean, okay? So that's the mean. Do you see how the blue, it's symmetric around the mean, right? And the red is also symmetric around the mean. So they're both normal distributions. But take a look here. Look at the blue. Do you see how all of the data is concentrated very, very close around the mean? But do you see how for the red, all of the data is distributed far from the mean? That means this red one has a higher standard deviation, right? Because it's more spread apart. So for a larger standard distribution, the curve is wider, all right? So it has a higher standard deviation, and that's the thing. Notice they both have the same peak, which is the mean, but the one with standard deviation is higher is a little bit wider. Okay. Now, look at these two. Are both of these normal distributions? Yes? Yes, because they are both symmetric around their means. So what happened here is the mean of a data set changed. First, the mean was the blue one, and now it's the red one. So when the mean changes, the whole graph shifts left or right, okay? So when the mean of the data changes, the graph shifts horizontally, okay? All right, now, here's the big idea, okay? Remember how we said every single data point is included underneath the normal distribution? Okay, it just so happens that when a data set follows the normal distribution, it is like the written law of the land that the same percentage always falls within the same range. All right? And so that's what we're going to call. It's so consistent that it's called the empirical rule. Okay? It's got two names. It's either called the empirical rule or it's called the 68, 65, 99.7 rule. Okay? And literally because those are the numbers that you use for the rule. Okay? All right. At some point, statisticians were just like, listen, let's just use the numbers. All right? Okay. So, for normal distributions, here's what happens. No matter how many people are in your data set, 68%, that's the first number, of all values fall within one standard deviation of the mean. Okay? So, this is the mean. Okay? So whatever the standard deviation is, right? Let's say the standard deviation for this one is, like 3 inches, like we said before. If you go to the left, one standard deviation, that's 34% of the data. If you go to the right, one standard deviation, that's 34% of the data. Together, in that region, you have 68% of all of your data. So if 100 people were surveyed, 68 of them will fall within that region. Now, if I go 2 standard deviations away, okay, so look at this one. Here is my first standard deviation. Now, if I go 2 standard deviations away, now that is 95% of the data, okay? So look at how it works. These two were 34, 34, 68, right? Now, if you expand, now it's 95%. So how much was added? 27%, right? Half of the 27 is on the left side and the other half is on the right side, okay? So this whole thing, 2 standard deviations up, 2 standard deviations down, the whole thing together is 95% of the data. But more accurately, in each of the 4 parts, you've got 13.5, 34, 34, 13.5. Complete and utter symmetry, all right? And so far we've done 68, 95, that's 2 numbers of the empirical rule. The next one, now if I go 3 standard deviations, that's 99.7 within 3 standard deviations. So from 95, how much more did I go? 99.7 minus 95. How much is that? That's like 4.7, right? 4.7 divided by 2, that's 2.35, which is about 2.4. So 2.4 here, 2.4 here. Okay? That's 98%. 99.7%. And then that leaves, right, like the 0.25, right? So we say it's 0.1%, 0.1%, like literally on the edges. All right? So this is the 68, 95, 99.7 rule, or the empirical rule. Okay? All right, so how do we use this? Take a look here. IQ scores have a bell-shaped distribution with a mean of 100, that's important, and a standard deviation of 15. What percentage of IQ scores are between 70 and 30? Okay, every single time, do a little sketch for yourself, right? So, bell curve, okay? The middle is the mean. This is 100. Okay? Standard deviation is 15. So, if I go 1 standard deviations, one standard deviation to the right, it's 115. And to the left, it's 85. I want to reach 70 and 130, so I gotta go one more, right? Let's go one more standard deviation. So from the 115, I go out another 15 until 130. From the 85, I go out another until 70. Okay, now, show me how many standard deviations did I go out of the mean? Who says 1? Who says 2? 2. So from the mean, I went out 1, 2 standard deviations. 1, 2 standard deviations. 2 standard deviations, that's 95% of the data, right? So all this, that's 95% of the data. So since we went 2 standard deviations, we say that's 95%. Okay? Questions? Okay, let's do a couple more. The heights of 880 students at East High School are normally distributed with a mean, that's what you need, a mean of 67 and a standard deviation of 2.5. Okay, tell me, what's the first step? What do we do? Draw. Yep, draw or graph, yes. And then I put in the mean, which is how much? 67. Okay, now it says about how many students are more than 72 inches tall. So I need to hit that 72 inches mark. So from the 67 to go to the 72, I don't have to go to both sides now, right? Because I just need that one side at 72. I'm just going to go to the right. Okay, so what's the first number? 69.5. Excellent. And the next one? 72. Okay, so here we go. Now, this is asking me how many students are more than 72. So that's what I want. Okay, that's what I want. I want this. So, from the 67 to the 72, what percentage is that? Yes, but it's only the first half of it. 40. So it's just 34 and 13.5, right? So this is 34. So let me do this. This is 34 and then 13.5. So this together is how much? 47.5, right? Is that right? So what percent is the blue? This is just the right half. So the entire right half is how many percent? 50%, right?
So it's 2.5.
Yes. So it's 50% minus 2.5%.
Can you just
I'm sorry.
add the other parts of the thing we just did?
You could.
Where it's like
You could do that. You could do that, yes. So this is 2.5%. But is that what we're asking? Is it asking for the percentage?
No.
It's asking for the number, right?
2.5% of 880.
2.5% of 880. All right, so remember, 2.5%, I move the decimal once, twice, 0.025. Of always means times 880.
Wait, why'd you move it twice?
Because it's percent, so you move the decimal. To go from percent to a decimal, you move it twice. It's like dividing by 100. Percent means per 100. So this is 22. All right, so 22 students. Okay. Okay. Now it says, what percent of students are between 59.5 and 69.5? All right, so let's draw another curve. I'm going to make a bigger one since I have room. This is the median at 67. Okay, I want to go from 59.5 to 69.5. So let's do one standard deviation on either side. 69.5 here. And on the bottom, 67 minus 2 is 65, minus another half, 64.5. Okay, I have to go one more. How much is that on this side? 62.
Wait, is it 64.5, the one in the middle?
Yeah. And then here it'll be 72. And then I need to go one more, it seems, right? Because I got to go to 59.5. So that's 59.5, and this one will be 74.5. Okay, so if you want to mark the divisions, I mean, it's up to you, right? So here's 1, here's 2, here's 3. Okay, what I want is to go from this one to 69.5, this one. Okay, so you see how like bookkeeping is important, right? And so now I just put in the numbers, right? This is 34. It's 34, 13.5, 2.4. Right? So these are the ones I want. Okay? So it's 2.4 plus 13.5 plus 68, 83.9. 83.9%. Okay? All right. Questions? So before I stop, what do we have to watch out for? First, you have to watch out for, keeping your data straight, like the mean, the standard deviation. Always draw a nice little curve for yourself. And then the most important part is look at what the question is asking you for. Is it asking you for the number, for the percentage? Is it asking you for the percentage or the number inside or outside of your boundaries, right? I mean, so just kind of, be aware, like, you gotta be woke, right? Like, just kind of, right? Like, yes. Okay. All right. So we're going to stop here. And the homework is a handout, which, okay.